book Ashok Talukdar, right? That is the great book for your GTU syllabus. Hello, students. So, the mobile computing can be defined as computing environment of physical mobility. The user of the mobile computing environment will be able to access data, information, or other logical objects from any device in any network while on the move. Now, what does it mean? I would like to say in different words. A mobile computing system allows a user to perform a task from anywhere using a computing device in the public, that is on the web, or they can access it from the corporate and personal information space like medical records, address book, from anywhere, anytime system is mobile computing. Now, while on the move, the preferred device will be a mobile device. That means it is not always mobile phone, but it is mobile device. While back at home or in the office, the device could be the desktop computer. So it is not mandatory that while you are using the mobile computing, it is always mobile device. It could be the desktop, palm top, laptop. Any device can access the information, data from anywhere, anytime. To make the mobile computing environment ubiquitous, it is necessary that the communication barrier is spread over both the wired and wireless media. That's why we have already seen that what are the wired media and wireless media. Okay, so be it for the mobile computing workforce, holidays, enterprises, or rural populations, access to the information and virtual objects through the mobile computing is absolutely necessary for optimal use of the resources and increased productivity. Now here I would like to mention the different name, right, refer in the context of mobile computing. The first one is mobile computing itself, that is, this computing environment moves along with the user. This is similar to the telephone number of the GSM system. GSM stands for Global System for Mobile Communication Phone, which moves with the phone. And the offline and the real time, that is remote computing environment, will move with the user. In the real time mode, the user will be able to use all his remote data and services online. That will come under mobile computing. Another name is anywhere, anytime information, and that this is a generic definition of ubiquity, where the information is available anywhere all the time. Then third one is virtual home environment. Now, VHE, that is virtual home environment, is defined as an environment in a foreign network such that the mobile users can experience the same computing experience as they have in their home or corporate computing environment. For example, one would like to keep the room heater on when one has stepped outside for about 15 minutes. Another name is nomadic computing. The computing environment is nomadic and moves along with the mobile users. This is true for both the local and remote services. Another one is pervasive computing, a computing environment which is pervasive in nature and can be made available in any environment. Another name is ubiquitous computing. That means nobody will notice its presence. Means every place computing environment. The user will be able to use both local and remote services. Another name is global service portability, making the service portable and available in every environment. Any services of any environment will be available globally. The another name given to the mobile computing is wearable computers. Means wearable computers can be worn by humans like a hat, shoe, or a clothes. So the wearable computers need to have some additional attributes compared to the standard mobile devices, right? So wearable computers are always on, operational while on the move, hands free, context aware, like that there should be some sensors installed in it. So the wearable computers need to be equipped with the proactive attention and notification. So the ultimate wearable computers will have sensors implemented in the body and supposedly integrate with the human nervous system. So these are the part of a new discipline of the research. Okay, so it is also categorized by cyborg, cyber organism also called, for the wearable computers. So these are the all names given to the mobile computing, right? So now what is the main function of the mobile computing? So we can define a computing environment as a mobile if it supports following characteristics, right? Like a user mobility, network mobility, bearer mobility, device mobility, then session mobility, agent mobility, host mobility. So the mobile computing can be defined as computing environment over physical mobility. The user of the mobile computing environment will be able to access data, information, or logical objects from any device in any network while on the move. Right? So, a computing environment is defined as a mobile if it supports one or more of this. Okay, so let's see what is user mobility. So, the user should be able to move from one physical location to another and use the same services is called user mobility. The service could be in a home or a remote network. For example, a user moves from suppose Ahmedabad to Delhi and uses internet to access the corporate application the same way the user uses it in the home office. The next one is network mobility. Network mobility deals with the two types of use cases. In one use case, the user is moving from one network to another and uses the same services seamlessly. For example, could be a user moving from a Wi-Fi network within the university campus and changing to the 3G network outside while using the same online services. And on the other hand, the other use case of the network mobility is the network itself is a mobile, like a mobile ad hoc network, manet we can say. So in a manet, each node in a network is a combination of a host and a router. As the nodes move, the router within a network also move, changing the routing table structure. And these type of networks are used in battlefield or sensor network, where routers and nodes are constantly moving. So these type of networks are called as network mobility. So along with the user, the network also moves. The best example is mobile ad hoc network, MANET you can say. Then we have bearer mobility. So the bearer mobility is the user should be able to move from one bearer to another and they use the same services. For example, could be use user could use the service through WAP, wireless application protocol bearer, in his home network in suppose Ahmedabad. He moves to Chennai where WAP is not supported and switches over to the voice or SMS bearer to access the same application. The next is device mobility. The user should be able to move from one device to another and use the same services. For example, could be the sales representative using the desktop computer in their home office. During the day, while they are on the street, they would like to use their palm top to access the application. So, same services are accessible even though he changes the device. It is called as device mobility. Then we have session mobility. So a user session should be able to move from one user agent environment to another. For example, could be a user using his services through CDMA. CDMA stands for Code Division Multiple Access Network. The user entered into the basement to park the car and got disconnected from his CDMA network, suppose, right? And he goes to his office and start using the desktop. The unfinished session in the CDMA device move from the mobile device to the desktop computer. So the same services, even though you are disconnected with your network, as we have taken example CDMA, still if you restart your services, you get the same service without break. So unfinished session can be restarted. So that is a session mobility, right? Then we have the service mobility. The user should be able to move from one service to the another service. Service mobility is also called as agent mobility. The user agent or the application should be able to move from one node to another node. For example, could be the uh, crawler software or even the malicious worm or a viruses software that move from one node to another node. There is another use case of mobile agent in the cloud computing paradigm is that the applications will be moving from platform to platform and infrastructure to infrastructure depending on the temporal and economic considerations. Now, in cloud computing, there will not be any fixed association between the application and the host running it. So, the software agent in the cloud will constantly be mobile. Next, we have the host mobility. So, the user device can be either a client or a server. When it is a server or a host, some of the complexities change. In case of host mobility, the mobility of the IP needs to be taken care of. The IP addresses needs to be taken care of. So these are the mobile computing functions or characteristics you can say that has to be achieved. Now, let's move to another topic. Mobile computing functions can be logically divided into following major segments. Right here in the diagram, you can see we have complete structure of the mobile computing. Here we have the device. Device could be a user handling any device, any mobile device or any desktop, palm top, laptop or any wearable device we talked about. Then we have the networks and gateways. So the networks are of the GSM, GPRS, ATM that is asynchronous transfer mode, frame relay, ISDN that is integrated service digital network, CDMA, CDPD, cellular digital packet data, digital subscriber loop, dial-up, Wi-Fi, 802.11, Bluetooth, Ethernet, broadband, any of the network could be there, right? Then we have the middleware framework where actual application server resides, right? Where your business logic is implemented. That is also called as adaptation framework, right? Then we have original server. Their actual contents are provided and the database from where the data is going to be fetched. So the user with the device is it could be the fixed device like a desktop computer in an office or a portable device like mobile phone. For example, laptop computer, desktop computer, fixed telephone, mobile phone, digital TV or set-top box, palm top computers, pocket PC, two-way pager, handheld terminal, anything. Anything can be considered as a user device. And networks also, I told you GSM, CDMA, iMode, Ethernet, wireless LAN, Bluetooth, CDMA, CDPD. We'll see all this network in detail, but for this moment, just consider a user is going to use the network for accessing the data. Then gateways. So these act as an interface between different transport bearers. The gateways convert one specific transport bearer to another. Let's take an example from the fixed telephone. With the voice interface, we access a service by pressing different keys on the telephone. And these keys generate a DTML, that is dual tone multi frequency signal. And these analog signals are converted into digital data by the IVR. IVR stands for Interactive Voice Response Gateway to interface with the computer application. Other example will be web gateway, SMS gateway. So the gateways are used according to the requirement. Then middleware, this is more of the function rather than separate visible node. Okay, so in the present context, middleware handles the presentation and rendering of the content on particular device. It may optionally also handle the security and personalizations for the different users. Then the content. This is the domain where the original server and content is, your actual data is. Now, this could be an application system or even an aggregation of different systems, and the content can be mass market, personal, or corporate content, could be anything, personalized content. And the origin server will have some means of accessing the database and storage devices. So, these are the basic overview of the mobile computing functions, right? So we will see all this function in detail one by one. Let's begin with the mobile computing devices. The devices for the mobile computing can be either a computing device or a communication device, right? Now, in the computing device category, it can be a desktop, laptop, palm-top computer. On the communication device side, it can be the fixed telephone line, a mobile telephone, or a digital TV. Now, usage of these devices are becoming more and more integrated into a task flow where the fixed and mobile computing and communication functions are used together. The device is a combination of a hardware and software. The hardware is technically called the UE, user equipment, with the software inside, which function as an agent to connect to the remote servers. And this software is called user agent, also called as UA, that is user agent. One of the most common user agent today is a web browser, right? Now, using the web browser, what you can do, you can access any services on the internet. When computing technology is embedded into equipment, the HCI plays a critical role. HCI stands for human computer interaction, right? So it plays a critical role in effectiveness, efficiency, and user experience. This is particularly true as the mobile information and the communication devices are becoming smaller and more restricted with respect to information presentation, data entry, and dialogue control. So the human computer interface challenges are, first one is in the interaction must be consistent from one device to another device. The second one is the interaction must be appropriate for the particular device and environment in which the system is being used, right? So that is how the mobile computing devices can be used. Now, uh, I would like to say another point, that the requirement does not call for the identical metaphors and methods. The desktop computer allows for a different interaction technique than the palm-top computers or digital TV. Using the keyboard and a mouse may be appropriate for the desktop computer. Now, using the pen may be appropriate for the palm-top or tablet PCs. So the microphones and the speakers may be appropriate for the fixed or a mobile phone. A remote control, on the other hand, will be more desirable for the digital TV. So the requirement can be changed according to the system you are using, right? Now, this is previous slide I would explain. Now the dialogue control, that is a topic we must know, that what is the use of the dialogue control. In any communication, there are two types of user dialogues. There are long session oriented transactions and short session transaction. For example, session oriented transaction is reading a few pages from one chapter of a book at a time, going to a particular page directly through an index, and reading a particular topic can be considered a short session less transaction. Now, selection of the transaction mode will depend on the type of device we use. A session may be helpful in case of services offered through computers with a large screen and a mouse. For device with limited input output like SMS for instance, short session less transaction may be desired. For example, consider inquiring about your bank balance over the internet. In case of internet banking through the desktop computer, a user has to go through the following minimum dialogues. First, suppose enter the URL of the bank site. Second, enter the account number, password, and login into the application. Third, select the balance inquiry dialog and use the balance. And fourth, log out from internet banking. So this example is session oriented transaction. Now using short session list transaction, the same objective can be met through the single dialog. In short session transaction, a user sends an SMS message, right? Blah, blah, blah. Suppose my balance is this to the system and receives the information on the balance. The application services, all the 5 dialog steps are on one dialog. In this case, steps like authentication and selection of the transaction need to be performed in the smarter way. For example, a user authentication will be done through the user's mobile number. It can be assumed that the mobile devices are personal, therefore, authenticating the mobile phone implies authenticating the user account. Okay, now I would like to move to another topic, that we have the types of network like wireline networks, wireless networks, ad hoc networks, and bearers. So first one is wireline network. So this is a network which is designed over a wire or tangible conductors. This network is called as fixed line or wireline network. Fixed telephone networks over copper and fiber optic will be a part of this network family. That's why we have already studied what are the types of fixed telephone networks. We have studied all the coaxial cable, fiber optics, all the wired media, right? So that will come under wireline networks. Now, broadband networks over digital subscriber line (DSL) or a cable will also be a part of wireline networks. Now, wireline networks are generally public networks and cover wide area. That's why we have also studied LAN, MAN, and WAN. Now, though the microwaves or satellite networks do not use wire, and a telephone network uses microwave or satellite as a part of its long haul transmission infrastructure. It is considered the part of wireline network. When we connect to the internet service provider, it is generally a wireline network. The internet backbone is a wireline network as well. Right, now the next one is wireless network. So the wireless networks are called as mobile networks. This includes wireless networks used by radio taxis, one-way and two-way pager, cellular phone, for example, PCS, Personal Cellular System, AMPS, Advanced Mobile Phone System, GSM, Global System for Mobile Computing, CDMA, Docomo, GPRS, WILL, that is wireless in local loop networks using different types of technologies, are part of wireless networks. In wireless networks, the last mile is wireless and works over a radio interfaces. And wireless networks, other than the radio interface, rest of the network is wireline and is generally called PLMN, Public Land Mobile Network. Now, third type of network we have is ad hoc network. Now, in Latin, ad hoc means for this purpose only. They are dedicated, spontaneously dedicated. So, an ad hoc network is a small area network, especially one with wireless or temporary plug-in connections. In these networks, some of the devices are part of the network only for the duration of the communication session. An ad hoc network is also formed when a mobile or a portable device operate in a close proximity to each other or with the rest of the networks. When we beam a business card from our PDA, personal digital assistance, to another, or use an IRDA port to print a document from our laptop, we have formed an ad hoc network. The term ad hoc being applied to a network in which new devices can be quickly added using Bluetooth or wireless LAN, that is 802.11. So these are comes under ad hoc network. They form ad hoc network because they are temporary. In these networks, the devices communicate with the computer and other devices through wireless transmission. Now, typically, based on short-range wireless technology, these networks doesn't require subscription services or carrier networks. Okay, so this ad hoc network is also a part of mobile computing, comes under networks. Then we have bearers. So for different types of network, there are different types of transport bearers. This can be TCP/IP, HTTP protocols, or dial-up connections. For example, GSM, it could be SMS and USSD. USSD is unstructured supplementary service data, or a WAP. For the mobile or a fixed phone, it will be voice. So these are the bearers by which you can transmit the data, right? So the SMS, USSD, or a WAP, right? Or your voice. So these will comes under bearers. Now the next topic is middleware and gateways. So this middlewares and gateways, any software layer between a user application and operating system is a middleware. Okay, any software layered between a user application and operating system is a middleware. So the middleware example are communication middleware, object oriented middleware, message oriented middleware, transaction processing middleware, database middleware, behavior management middleware, remote procedure call middleware. So these are some middleware components like behavior management middleware, which can be a layer between a client device and the application. So in a mobile computing context, we need different types of middleware components and gateway at different layers of the architecture. So it is not mandatory that we need all these middlewares in your communication. There may be chances that you need two to three middleware or maybe only one. It depends upon the requirement. The middlewares can be used. So let's begin with the first middleware, communication middleware. So the application will communicate with the different nodes and services through different communication middleware. So different connectors for different services will fall in this category. For example, TN3270 IBM mainframe service uses this, or a Java mail connector for IMAP or POP3 service. So these are the middleware, communication middleware. Then transaction processing middleware. Now, in many cases, a service will offer session oriented dialogue, SOD. So for session, we need to maintain a state over a stateless internet. Now, this is done through an application server. The user may be using device which demands a session-less dialogue, SID, made of short sessionless transaction, whereas the service at a backend offer SOD, that is session-oriented dialogue. In such a cases, separate middleware component will be required to convert SOD to SID. So the management of the web component will be handled by this middleware as well. Next middleware we have is behavior management middleware. Now different devices deliver differently. We can have the application which are developed specially to deliver in the certain manner. For example, we can have one application for the web, another for the WAP, WAP, and different one for SMS. Now, on the contrary, we may choose to have the middleware which will manage the device specific rendering at runtime. So this middleware will identify the device properly and handle all the device specific rendering independent of the application. The system may be required to have some context awareness, which will be handled by the behavior management middleware. Next one we have is a communication gateways. So what are the purpose of this communication gateways? So between the device and middleware, there will be the system of a networks. Now, gateways are deployed when there are different transport bearer or a network with dissimilar protocols. Okay, when we have different transport bearer or a networks with a dissimilar protocols. For example, suppose we need an IVR gateway to interface voice with computer or a web gateway to access internet over mobile phone. So these kind of gateways are helpful when we have different protocols or different networks. So these are all about the middleware and gateways. So the next topic which we have the application and services that we will see in next lecture. Thank you students for this, and let's see